Hello everyone, this is Debabrata once again, and today I'm planning to take a class on circular link list. So circular link list is not going to be tough. It will be another easiest class because most of the programs we are going to copy and paste simply. For that, as a prerequisite, I will recommend you just to have the basic idea of the linked list, just the basic operations like in how to insert, how to delete from a normal linked list. That will be enough. I'm not talking about double linked list, the simple linked list I'm talking about. Okay, that we called as a singular linked list. So the basic idea of that will be enough for this class. So there is actually no basic differences between single linked list as per the structure. There is no difference at all between single linked list and circular linked list. The only difference is here at the very last node. I mean at 40, you can see 40 is not pointing to any other node. It is basically null here. I mean here it is not pointing to any other node. It is not pointing to any other node. So it is blank actually. In technical terms, we call it null. So it is basically null. In circular linked list, the only difference is it will point to the head node again. So that means the last node will point to the first node. And that's why we call it circular linked list. So structure wise, no difference at all. Even operation wise or anything, no differences at all. We just need to take care of the last node pointing to the head. That one thing we need to take care. So obviously, just imagine, if you have the common sense, just it is very easy to imagine, like whenever we will be inserting or deleting something at the starting or at the end, then there will be some differences. Otherwise, if you are adding or if you are deleting something from the middle, anywhere from the middle, there will be absolutely no change at all. And that's why in today's topic, I'm not going to show you anything else because the rest of the things will be same. Only four programs like this. Whenever we are trying to add or delete something from the ending or beginning, that's all. Because rest of the things will be exactly same. So if we start from insert at ending, and let me go to the code. Here I can create another node, but again, it will be going to be the same structure. So exactly same. So I do not need to do anything here. I can simply reuse that. The only difference in circular linked list is we have to take care of the last node. Last node should point to the first node. That's all. So if I just go to linked list and just copy the program, and here, if I just create a new class called C linked list, means circular linked list. And if I just copy and paste the program, so it will be enough, I guess. I do not need to change anything. Let it point to node, the same structure. So let me start with insert at ending. So, okay, let me compile first. Yep. So there is nothing. Again, do not worry much. Don't worry, just we will do it step by step. That's all. That will be enough. So I will again create a node somewhere in the memory. You know the logic now. We have done quite a lot of time. So if we just create somewhere here, so we name it called box as per the highlighted code, highlighted line. So we call it box. Suppose we will enter somewhere 10 here. And okay, let me uh, make two parts. The first part is integer, second part is node. So if it is the new one, so by this line, sorry, where is the line? Node box, new node, it will create the some a box somewhere in the memory. And now I'm checking if head is null. Yes, there is nothing, no circular linked list exist for the time being. So head is obviously null. So what I will do, head equals to box. So I will just do head equals to box simply. And here I have to add an extra line just to create that it is the first node, it is the last node as well. So what the only thing we have to take care in this class is the last node should always point to the first node. So here we have only one node. That's why I can write something like head next equals to head. So this is the first node and this is the last node. That's why I am writing the node pointing to itself. That's all. So if you just if you just remember one fine line, the line is the last node, you have to take care only this thing. The last node should point to the first node. And that's all we need to take care in this class. So here, this is the last node and this is the first node. So it is pointing to itself. So I have just written again, one or two extra lines will be enough. Here I have written head next equals to head, and that is enough. So next turn, suppose again someone is looking for inserting something at the end. So what he or she will do? So node box equals to new node. So this line will create another box somewhere in the memory, something like this. So suppose in the box we are going to place 20. So that will be called box. Okay, I forgot to make one change. Like the 10 will be called as head now. It is no more box. So let me delete the box. Yeah. So it looks like this now. So now the program will come to the second line. We have done it quite a lot of time. If head equals to null, no, now head is not null. We have 10 in the head. So head is not null. It will go into the else block. So I will place something node equals to temp. So temp will start from head. So here, every time in previous singular linked list programs, we used to write iterate temp until temp dot next become null. So here, no more null. We are going to use the head. That's only the change we need to do here. So temp will start from head until temp next is not equals to head. But here, if we name it as a temp is starting from head. But you can see temp next is already head. It is the only node available in the linked list. So we will stop here. And here we are going to make the connection. Temp next equals to box. That is the usual one we do. We did it quite a lot of time. So again, we are going to do that. So what we will do, we will make a connection from temp to box. Temp next equals to box. You see? So the older connection will be disappeared. So temp is now equals to box. And the last one, we have to make another change. The only line we will take care now, the last node should point to the first node. So that means we are going to write this line, box dot next equals to head. So we have to follow that line in this particular class. That is the only concern. So the last node box next is going to point to head. And that's all. And it will be like that. Again, if you just imagine, again, if I just go through, suppose the user has entered again, user wants to go again with insert at ending. So what it will do, it will create another box, something like this. Okay, let me remove the older one, the box. Yeah. So it will create another node called box if they wish to go with insert at ending once again. Box, yeah, something. So the next line, okay, this is the first line, node box equals to new node. So 30 is entered with a name like box. Head is null, of course not. I can see something, a lot of thing in the linked list. So head is obviously not null. So here node equals to temp will start from 10. So if I just draw very quickly, temp will start from here. So it is going to check like temp next is not equals to head. Yes, true. The next of temp is 20. It is not head. So just go on. So it is saying it is a empty for loop. So it is just saying to go to the next node. So temp simply will move from here and it will go to the next node here on 20. So now again the same question. Temp next not equals to head. And it is false now because 20 is pointing to head now. The next node of 20 is head. So it is not true. The loop will be stopped here. After the loop, this line will be executed. Temp next equals to box. So temp will be pointing to the new node now. So if I just remove this connection, and now temp is going to point the box. It is the older way. It is the old code. Actually, we have done it quite a lot of time. And now, as a last line, you can see it is written box next equals to head. So this is the new line. And this is the thing we need to take care in this class. That the last node that is boxed, that box next should point to head. So the last node should point to the first node. Very simple. So here, if you just compare neck to neck, here in the else part, we have made two small changes. One change is here. So the last node is not going to be null anymore. It is going to be head. And we need to make that connection. We need to take care like last node should always point to the first node. So that two minor change we have made. And that's all. That's all for insert at ending. So if we just check few more examples like delete from ending, how to do that. So again, I'm interested to reuse the code. Delete from ending, where is delete from ending? If I just, okay, yeah, let me make this code very easy because insert at position and everything is going to be the same. Okay, because if you do some operations in between it is going to be the same because single linked list, the structure of single linked list and a circular linked list is exactly same. Okay, so no more changes there. Only changes will be there if you are manipulating first node and last node, because in circular linked list, this is the point we have to take care. The last node should point to the first node. That's all. So the only differences will be there when you are trying to manipulate the first and last node. Everything, rest of the things will be exactly same. So no need to do anything there. So delete from ending, the same thing if I wish to delete the 30, suppose. So what I will do, if head is null, obviously list is empty, we are not going to do anything. Otherwise, temp and temp2, I'm going to take two variables. And okay, temp2 will be null. And here I will start from temp equals to head. I'm just trying to remember what we have done in our single linked list class. So temp will go till the end. Obviously here I just need to replace it with head, and temp2 equals to temp. So temp2 will go slowly behind temp and temp will go fast. So here, after this for loop, what will happen? We have done it couple of times. If you have any doubts, I will request you to just to check the previous program, or I can explain a bit as well here. But again, we have done it quite a lot of time earlier. So here we are doing, it will go until temp next is not equals to head. So temp will end up here because at this point, temp next is head. So the next node of 30 is the head node again. So temp will stop at 30. Temp2 is going behind of temp. So temp2 is taking the value of temp and temp is going for the next node. So temp2 is one step behind of temp. So temp2 will now rest on 20. So at the end of the for loop, temp will rest on 30 and temp2 will be on the top of 20. So that's where we ended. So we made a very, very small change here. Instead of null, we have given head. So temp2 next is null. So temp2 next is null, means the connection between 20 and 30 will be deleted. Let me delete that right away. This is the old code. I'm not going to change any single thing here. So after that, it is printing like, okay, temp data is deleted. That is fine. It will print 30 is deleted. Very good. No issue. So here I'm doing temp equals to null. That is also fine. But here I prefer to write two more lines before this. First is temp dot next is null. It is not mandatory, but still you can give it. It is not mandatory because if you are deleting something, no need to manipulate anything there. But I am interested to delete this line between temp to head. That's why I have given temp next equals to null. I'm not interested to keep it before it die. So, and again, that line, the last node should point to the first node. So what is the last node now? That is temp2. So now from here, temp2 should point to head. And that's all. And after that, you can remove temp, whatever you can do. So that is the idea. So this line is mandatory. Temp2 next is head. By doing that, what I'm going to do, the key line of today's class, the last node, whatever it is, that should point to the first node. That's all. That's all we need to take care. And the previous line, it is optional. You can give it because it is anyhow, it is going to die after that. So you can give it, you can ignore that, no issue. And a very small minor change like temp next now will always point to head. So if you want, I can copy this for loop as well. So this will be a useful for loop now on. So here every time, okay, I do not need temp2 in future cases. So here temp next not equals to head. Previously, it used to be like temp next not equals to null because the last node is going to hold the null, but now it is going to hold the head. So that is the useful for loop we can use later. So that's the thing. If you have any doubt, you can just play this part once again, and still if you are not clear, just let me know. But again, if you are clear with single linked list program, the only line you have to take care here, this line, you have to just always remember, like whatever happens, the last node should point to the first node. And the easiest part is you have to take care, you have to remember these things only when you are manipulating the first and last node. If you are manipulating something in between, you do not need to remember because it is going to be the same. So now let me take a look into delete from beginning. So suppose you have okay, let me go back to the this one, yeah, 10 20 30 something like this. So now, okay, temp is not there anymore for this program say, yeah. So it is our very pretty much healthy linked list. So now if anyone is looking for delete from beginning, deleting the head node, that is 10. So if head is null, no option, you can print list is empty as usual. Otherwise, put temp at the head and move head to the head next. So first, if I just write temp equals to head, so temp is going to stay here. And now before moving the head, it is a very crucial step. If you just change the definition of head, then it will be very tough to go till the end because at the end, it is still pointing to 10. So we cannot quickly move the head from 10 to 20. First, we have to reach out to the end. That is the extra part here. And for that, if I just copy this code, that will be good, I guess. So I'm just planning to copy this code, and here I'm planning to take a new node called last, say something. So first I have to, the first step is go till the end, or I can put it like end. So end will be starting from head until end next is not equals to head, and end equals to end. The same thing, the same loop, I just changed the variable name. So what it will do, it will reach till the end. So end will reach at 30 by using the same loop we have used in the previous program. So before moving head, I am planning to reach till the end. So by this for loop, end will reach till the end. Okay. So you can see end is now resting on the top of 30. So that was my plan basically. So here, if I just give a blank brackets, yeah. So now you can do whatever you want, whatever you used to do in singular English programs, like head equals to head next. So I can move head to the next node. Let me do that very quickly. So I'm just changing it in graphically. No changes required in the code. So head equals to head next. So head will move into the 20. Then temp next equals to null. So that means the link between 10 and 20 is going to be deleted. Let me do that. Yeah, it is deleted now. Now, what is the next line? In the next line, it is showing temp data is deleted. Yeah, you can print in the screen like 10 is deleted. Fine. So what next? Temp equals to null. Yeah, you can just delete temp at all, means you can fully delete 10. Yep. So what will be the remaining line now? You can guess. The reason I put end till the end, just to take care of this line. The last node should point to the first node. Only because of that, I introduced this for loop. Just because of that, trust me. So here, the only extra line will be end next equals to head. Okay. That is the reason before moving the head, I just introduced this for loop just to just to mark the last end, just to mark the 30. So now what will happen? Obviously, this line is not going to be there anymore. So what I will do, there will be a line between last node to the first node. And how we are going to make that? First, we need to place end at the very end by using this for loop. And another extra line here, that is the main line actually, end next equals to head, which will take care the connection between the last node and the first node. That's all. That's all my concern. Okay, we do not need to think anything else. Just just concentrate on this line. The last node should point to the first node. That's all pretty much. So if I just go to the next program, insert at beginning, and suppose we are interested to insert something at the beginning, what we need to do? If I just go to the program once again, where is the insert at beginning? Yeah, here it is. It is a very small program I can see. So node box equals to new node. We can introduce a new node here. If I introduce a new node called box, suppose. So suppose a new node here, we name it as box, say the similar structures like the single linked list, and we are going to insert here as 10, something like that. So how you are going to do that? So node box equals to new node, we are done. If head equals to null, then head equals to box, and the same line, if I copy from here as insert at ending, if you have only one node, then that node should point to itself. So head next equals to head. That line we have already discussed. Obviously, the thing is, like, if you have only one node, that is the last node and that is the first node. So you have to write this line to maintain the idea of circular linked list. The idea of circular linked list is again this one line, the highlighted one. The last node should point to the first node simply. So to maintain that, I have to write this line. Else, what I need to do? Box next equals to head. Yeah, perfect line. We can go with this. So if I just draw box next equals to the head, perfect. And then what is the next line? Head equals to box. So head is going to move from 20 to 10. But before doing that, before we do any manipulations in head, we just need to reach out to the end. So if I copy the code, where is the code? Where is the code? Here it is. If I just copy this code, if I just copy this code, before manipulating head, I just want to introduce this end one. So what it will do, it will reach out to the, sorry, where is the program? Where is the program? Yeah, here it is. So what I'm trying to plan, I want to place end at the very last node. I have already did that. I have already done that, end at the very last node. Now you can do whatever you want. Oh, where is the program? Sorry, this is the one. So now you can link temp next equals to box, whatever. You can, okay, sorry, I'm doing something wrong. Oh, sorry, where is the delete from beginning? I messed up everything, or I messed up everything where I have copied. Okay, let me do Control Z. Yeah. So now if I just copy and paste, not here, sorry, where is that? Yeah, insert at beginning. So box next equals to head. Yeah. Then if I copy this, node end equals to something and end till the end, it is fine. Now I'm just going to do this line. Head equals to box. What it will do, it is the existing line. I have not changed anything here. So I'm just going to place head on the top of 10. I have done that. And the last line, you know that what I need to do. I need to point the last node to the first node. So end next equals to head. So that's all we need to do. So graphically, what it will do, it will make a new connection from 30 to 10. And that's all. 30 to 10. That's all. So as a summary, what we have done, we have introduced something as end that I point to the last node, that is 30. And at the very end, I made the connection between 30 and 10. Remember, you have to introduce your end before moving head. Okay, before moving head. Otherwise, this loop is not going to find the real head. Okay, so that's the purpose. So that's all about our topic one. The main four operations that will be a bit different from singular linked list. The rest of the programs will be exactly same. We will not going to check that because no changes are there. So the last topic, that is how to display. Only one program here. So we haven't executed our program yet. So that is the last part. We have to display the program. So if I just, we have to display the linked list. Where is the display program? If I just take a look. Okay, let me delete everything else because it is not needed. Where is display? Here it is. So display is okay. Let me delete this first. I really do not like those long programs. I really feel scared. Okay, let me delete everything else. No need to have those big things. Okay, I can paste the program in the code blocks as well. If you want to try, just try. If it is not running, just let me know. But I prefer to run it by yourself. Then you will make some mistakes, and those mistakes is very necessary in our journey, because if you do mistakes, then you will concentrate and then you will be fully involved with the program. Otherwise, if you just copy paste, you will not able to see or able to feel the minor changes of this program. Okay, it will be that minor, you will, the high chances is you will skip that changes. So if you try to write those program by yourself, then only you will do the mistakes and you will learn. So that is my idea. But still I will paste the code because it is the long codes, and the interview as well, they will not going to chase you for the codes. They will ask you for the concepts, they will ask you for the algorithms only. So it will be enough if you describe at the interview panel. So just to describe the concept, no need to write the code. But if you prefer coding, you can write the code even. I'm just saying because code is, I feel code is bit tough because you have to take care all of those single semicolons, single brackets, everything. But algorithm is pretty simpler than the code, because you have just to need to explain in your own way. You do not need to follow any particular way. You just need to explain. That is enough in the interview round. Trust me. So how to display? Obviously, if head is null, we are going to show like a list is empty. No doubt on that. But if it is not, then we are going to print like, okay, list is like below. We are going to start from head until if I just put it like temp not equals to head, it is not going to print anything. Why? Why? Just try to think. If I just draw that thing here, suppose, if I just try to replicate the code, so temp will be starting from head as per the code. Where is the code here? Temp is starting from head. You can see this part. Next, it is saying it will run until temp not equals to head. In this part, temp is already head, so it is not going to run. To run the for loop, it is required temp is not similar with head. So here temp is similar with head, so it is not going to run. So here we have two approaches we can follow. That is, run the program until temp next equals to head. So temp will stop here as usual, as per our famous for loop. I mean the for loop we have copied here in the from the early previous programs. We have used it a couple of times today. Temp next not equals to head. So I can use the same program to print everything except the last node, because it will stop at last node. It is not going to, if it is stopping at last node, it is not going to print the last node. Okay, so it is going to print 10 and 20. So to print the last node, what we need to do? We need to print the last node separately out of the for loop. And I think that is enough. Okay, just I need to do one thing. Node temp, I have to make it here outside of the for loop. Otherwise, it will not going to recognize the temp. So that's the idea. Let me run this program. So all the printing lines inside the for loop, just one printing line outside of the for loop just to print the last node. Otherwise, it is not going to run. So if I just go to this program and if I try to run it for the very first time today, even I have to check if I have written all the programs correctly or not. Okay, it is compiling. If you check at the left bottom corner, it is still compiling. Okay, let me wait. My machine is really bit slow. It is taking quite a long time to compile. Okay, so it is already done. So if I just create a new link list with my name, like Debu, say. Okay, so if I just, we have only 5 functions or 5 activities. That is good. If I just try to do something like insert attending. So suppose if I entered 10 and now if I just, okay, sorry, not yeah. If I just insert attending 20, if I just insert attending 30, if I just insert attending 40, I think that is enough. So if I just display, it is going to print 10, 20, 30, 40. Take a look. So this 40 is actually being printed from the outside of the loop. Okay, and this 10, 20, 30 is being printed by the for loop itself. Okay, so that is how you can display a linked list. Where is the display? Where is the display? Here it is. Okay, if you put temp not equals to head, it will not going to work. So, and why I put it? Why I put it as a separate topic? Then it is a it is an interesting thing. Like why I put it as a separate topic, I can put it with the previous one. But this is the perfect use of do while loop. I face a lot of questions in my Java classes, like why Java introduced this do while loop, why Java introduced while loop, and several questions like that. So basically, the main reason of introducing do while loop is just to handle the situations like this. The situation here is it is circular. So in this case, do while loop is a good one to work with. So what we do generally with the while loop, in while loop, we just copy the first line outside of the loop. I have discussed that in one of our Java for loop classes. It is very simple. Okay, so you do not need to run your brain. The last line, temp equals to temp next, as the last line of the loop. That is the standard way. If you compile this thing, it will work. So while loop is simply the difference between for and while. It is working. Okay, I call it personally, I call it broken for loop. So you can run this program with this, it will work. Or you can put a while loop here, just removing the semicolon, that will be enough as well. So that is the only difference between while and for loop. Many people ask me what is the difference between while and for. There is nothing, no differences. Again, I'm telling this in my online class. If you have experienced any differences between while and for loop, just let me know. So just if you remove the first line outside of the loop and the last line as a last line of the loop, it will be enough. And just replace the word for with while and remove the semicolon. So otherwise, it is just structural changes. Otherwise, no difference at all. If you follow this line, all the for loops can be converted into while. Okay, if you have experience something different, just share that. Okay, just share that idea. Otherwise, it is I have until in my career I have found like it is same. Okay, so now why we are going to use do while loop? So in do while loop, what we do generally, we can write do here and the line of while we pasted at the end. So here in do while loop, the first checking they skip. The first checking they skip. They just enter into the for loop, enter into the loop, better to say. They print the data, go to the next node. Then from the second round onwards, they start checking. And that is ideal for this situation. So we do not need to print anything after the for loop, after the loop. Sorry, again, I'm just telling for loop. It is not. So after the loop, but again, everything is same. So do while loop has this extra feature. Like for the first one, it is not going to check like temp is not equals to head. So we can survive with this condition. So for the first time, it is not going to check is temp equals to head or not. It is not going to check. So first turn, it is going to print our value. If I just go to the our linked list, it is going to print 10. Then it will go into the next node. So if I just move to the next node, so temp is now on the top of 20. And at this time, okay, let me delete this one. Yeah. So now it is no more equals to head. So temp not equals to head. Yes, true. 20 is not head. So now again print 20 and go to the next node. And it will go like this. It will go like this. So if you use do while loop, you do not need to write the extra line outside of the loop. That is the concept. But again, if you feel all this concept very tough, I will prefer to survive with our old way. We haven't used do while loop till this class, so you can anytime survive with your old code. Okay, so just you need to write one extra line outside of your loop. That's all. It might be while loop, it might be for loop, anything. So now for the last time, if I just run the program again, so let me create a linked list with my name called Buha. If I just insert from beginning this time, so let me insert 10, then insert at beginning 20, insert at beginning 30. I'm just going to test as well, like, okay, if everything is working or not. Insert at beginning 40. So the linked list might look like 40, 30, 20, 10. So if I just do the display, look, it is working 40, 30, 20, 10. And let me quickly test the delete from beginning, those options as well. If I do delete from beginning, then 40 should be deleted. Yes, it is showing. I am afraid of if I have missed anything or not. Yeah, everything is working perfectly, 30, 20, 10. Now, if I delete something from the ending, it is going to delete the 10. Yep, it is also working. If I just take a look into the display, it is 30 and 20. Yep, it is perfectly working then. So that is the idea of circular linked list. Nothing much. Don't take tension. If you are not even able to understand the logic, just I will recommend to revise the class. Before that, revise the normal linked list class. If you are good at linked list, you can do rest of the things. Double linked list, circular linked list, everything is same. So we have exercise as well. If I just go to our Facebook group, you can follow that. If you want, you can go to media. You can now go to the albums. My machine is a bit slow. Yep. So you can go to the album. There you will find one album with the data structure exercise. Where is that? Yeah, here it is, data structure exercise. And there you can find few questions on the same questions like singular linked list. But yeah, here it is. You can find it as a circular linked list. The same thing, you can see, same thing. You can try some other options as well, like insert at position, insert after a value, but you will find the same code with no changes, Okay. If you need to do any single changes, just let me know in the comment section, but it will be exactly the same. The changes will be there whenever you are manipulating the first and last node, because the concept of this circular linked list is last node should point to the first node. So only changes will be there if you try to manipulate the last node or the first node. That's the thing. And that's all for the day. Nothing big, just the same thing we have just revised. If you have any doubts, just let me know. Otherwise, see you next time with some new classes. Bye for the day.